Okay, all right. We'll start. I hope I'm audible and visible. Right, we'll start. I'll check from my end also. Okay, all right. Okay, it's working fine. I hope I'm audible. Right, start. Okay. Right, we'll start. Okay, so we are meeting at a point where you are like 8 days from the exam, right? You are like 8 days from the exam. And about the S2A discussions, now we are doing it for the 25th day today, right? The S2A. So if you are with the S2A discussions from the beginning, I'm pretty sure that you might have, you should have grabbed many things from these S2A discussions, right? I have discussed all types of questions in these S2A discussions like MCQs, structured essays, and then now the paper series is also going on, right? Provincial papers, support seminars, right? Many things, no? Okay. Now, without further ado, we'll start. If you didn't get the paper, you can get it downloaded from the pinned link that I have pinned in the live chat, right? You can get it from there if you haven't got the paper yet, right? There was no English translation available for the paper, so I had to translate, right? I had to translate, and in that copy there, first 25 questions are there because today we are having the first day, no? First day of the first part of the discussion, no? For the second part, I will send you the remaining 25 as well. Right. Then we'll start without any ado. Okay, this is the Southern Provincial paper. So far, I have discussed what are the papers? So far, I have discussed support seminar, Western Province, Central Province, right? And yeah, now today we are in Southern Province. We are in Southern Province discussion. Okay. Then question one. Question one. The unit used to measure the harm caused to an object due to the amount of radiation absorbed. Absorbed dose, we call this absorbed dose, right? So that is popular among us as, right? That is popular among us as absorbed dose. Absorbed dose is measured in sieverts, right? That's a straight theory question, right? There are only two SI units are given in the list. Becquerel. Becquerel is the SI unit of activity or radioactivity. There is a SI unit of radioactivity, and Gray is not SI. Radiance is angles. Rem is also not a SI unit. Rem is also not a SI unit, right? Sieverts, very straightforward. Second one, the dimensions of coefficient of viscosity are, right? You should be able to keep that in mind, ml minus 1, t minus 1, right? ml minus 1, t minus 1. And if there's anyone who don't know it, I will just show you the calculation. Otherwise, you should know dimensions of viscosity because that's a popular one with us, right? F equals 6 phi eta RV. If I use Stokes equation, right? Then force is mlt minus 2, right? 6 phi is dimensionless. Then I need eta, radius is L, V is LT minus 1. Then eta is given by M, L minus 1, T minus 1. Right? Simple as that. 3. Which of the following principles express the conservation of energy? Very straightforward again. Bernoulli's principle. Right? Because it is about the addition of pressure energy. Right? Half rho V squared, kinetic energy by unit volume, rho GH, potential energy by unit volume is a constant. So that is a conservation of energy. There is a conservation of energy. Right? That is a conservation of energy. 4. The wavelength of a wave is the distance along the line of wave propagation between particles that have equal. The wavelength of a wave is the distance along the line of wave particles. Again, a straight theory. Wavelength is defined as, that's the definition. Wavelength is defined as the shortest distance between 2 points at same phase. Right? Wavelength is defined as the shortest distance between 2 points at same phase. Right? If the wave is like this, right? Shortest distance between any 2 points at the same phase. Shortest distance between any 2 points at the same phase. Any 2 points at the same phase. Like this. Now for this one, the same phase one is here. Okay? This is called the lambda. So that is again a very straight one. That is phase. Right? 5. A man of mass 75 kilograms runs at a speed of 5 ms minus 1. During morning exercise. What is the de Broglie wavelength associated with him? Planck's constant is given. Okay. We have only one equation for de Broglie constant. No? Then such ones are very straightforward. We have only one equation for de Broglie. Lambda equals HOMU. Right? Then lambda equals H is given 6.6. 10 to the power minus 34, over mass is 75, right? And the speed is 5, right? So that is 6.6 over 75 times 5 is 375, right? 375. 10 to the power minus 34, right? Simplify this. 66 over 375 is, so what's coming is 1.76, 10 to the power minus 36. 1.76, 10 to the power minus 36. 1.76, 10 to the power minus 36. Right? Six. When an astronomical telescope is used in normal adjustment, its angular magnification is 12. Okay. We know angular magnification of a astronomical telescope is given by f over fe. Right now, this is 12. Then 12 equals f over fe. Right, which means FO equals 12 fe. FO equals 12 fe. Right? The distance between the two lenses is 78. So we know at the normal adjustment, distance between two lenses is equivalent to FO plus fe. FO plus fe. Then 78 equals FO plus fe. We need IPs. Then FO is 12 fe plus fe. 78 equals 13 fe. So fe is 78 over 13 means 6. 78 over 13 is 6. 6 centimeters. Right? 6 centimeters. Straightforward again. 7. A glass block of refractive index 1.5 and height 3 centimeters is placed on a printed paper. When viewed normally from above the glass block, the apparent displacement of the printed letter is. the apparent displacement of the printed letter is, right? So either you can use the normal equation, n1 over n2 equals real depth over apparent depth, and the apparent displacement is the difference between real depth and apparent depth, or else you can use the direct equation of apparent displacement. D equals T times 1 minus n2 over n1. N2 is observer's medium, n2 here is observer's medium, n1 here is object's medium, right? Then this is given by thickness, T is thickness is 3 centimeters, then 1 minus observer is in air 1, and the medium here is 3 over 2. 1.5 means 3 over 2. Then D equals 3 times 1 minus 2 over 3. Then D equals 3 times 1 minus 2 over 3 is 1 over 3. So apparent displacement is 1 centimeter. Apparent displacement is 1 centimeter. Right? Straightforward again. 8. 8. A boat moves at a uniform speed of 10 ms minus 1. The resistive force acting against the motion of the boat is 400 newtons. The power of the engine of the boat is, right? The only relationship we have between power and velocity is P equals Fv. Then the traction force is the force equivalent to friction or the resistive force if that is moving with a uniform velocity. Then this is 400 into V is 10, P is 4000 watts, right? 4000 watts. It's 4000 watts. 9. Which of the following cannot exist for a moving object with a finite mass? Finite mass means, right, that's a non-zero mass. And there is not infinite, a finite mass. There is not infinite, there is a finite mass, right? Then if there's a mass and if there is moving, there's a momentum. Definitely there's momentum. If there's a momentum, right, and velocity and a mass, velocity is there, then velocity and a mass, kinetic energy is there. Mechanical energy is the addition of kinetic energy plus gravitational potential energy. So this is also there since kinetic is there, right? And there cannot be a gravitational potential energy, right? No MGH. That we can say, right? 10. A certain transformer has 900 turns. Transformers. In the last essay discussion I discussed about the transformers, right? And we did the calculation using transformers. Transformer has 900 turns in its primary coil and 30 turns in the secondary coil. When an alternating voltage of 240 volts is applied across the primary coil, the voltage of the secondary coil is. Okay. So we know equation of a transformer is V1 over V2 equals N1 over N2. 1 is the primary coil, 2 is the secondary coil. Then voltage of the primary coil is 240. We need the voltage of secondary, right? And number of turns in the primary 900. Number of turns in the secondary 30. Secondary 30. Then simplify. This is 30 times 30, no? 30 times 30. Then V2 equals 24 over 3, that is 8 volts, right? 8 volts. Simple, right? Just a matter of knowing the equation and simplifying. 11, right? This is the Southern Provincial paper. So as a paper, this is a very similar paper to the past paper, Southern Provincial paper. Provincial papers are always having some kind of a higher gravity compared to other papers, right? 11. For the formation of real image of a real object by convex lenses, which graph best represents the variation of 1 over m with object distance u, where m is the magnification. Okay, we know if the real images are formed, right, always real images are formed in front of the lens, right? Always real images are formed in front of the lens, right? In front of the lens. Then if you apply lens formula 1 over v minus 1 over u equals 1 over f, right? Now in front of the lens means image distance is minus, object distance is plus, but plus minus is minus, and this is a convex lens, f is minus. Then the equation is 1 over v plus 1 over u equals 1 over f if you multiply by a minus sign again, right? Then since I need u, multiply the entire equation by u, then this becomes u over v plus 1 equals u over f. U over v is not magnification, magnification is v over u. This is 1 over magnification. Then 1 over magnification plus 1 equals u over f. 1 over magnification is in the y-axis, right? 1 over magnification is in the y-axis. Then 1 over m equals 1 over fu minus 1. Identify variables. C, this is x, then this one is m, this is y, then y equals mx minus c. Y equals mx minus c. The only mx minus c curve given here is 3. The only mx minus c curve given here is 3, right? Then quickly you can get into the question. Quickly you can get into the question, right? Quickly you can get into the question, right? Graphing, huh? That's graphing. 11. A tuning fork is in resonance with a sonometer wire. Consider the following statements, right? Consider the following statements. A stationary wave is formed in the wire. That is correct, no? Right? In sonometer, that's a stationary wave. That we know. Stationary wave, yes, correct. That is correct, that we know. Then B, if the tension of the wire is increased, the resonant length increases. Resonant length increases. No, resonant length depends on the length of the wire. No? Resonant length depends on the length of the wire. If the wire is unchanged, if the length of wire is unchanged, right? This is unchanged. That is wrong. See, if it resonates in the fundamental mode of vibration, the amplitude of the vibration is maximum. Yes, because in the fundamental, amplitude is maximum. In the fundamental frequency, amplitude is maximum. In the fundamental, amplitude is maximum. Then A and C, right? That is A and C. That is A and C, right? A and C. 13. 13 again a theory question. 13. Two equal mass samples of a certain ideal gas is at a standard temperature and pressure STP were compressed. One sample was compressed isothermally. Isothermal means delta T is 0. Isothermal means delta T is 0, right? To exactly its half its volume. And the other sample was compressed adiabatically, right? Adiabatic means delta Q of the process is 0. No heat exchange. To exactly half of its volume. At the end, which of the following is equal to both samples, right? So we know delta W is written as P delta V. No? Delta W is written as P delta V, right? Thermodynamics. Delta W is written as P delta V. Now it says pressures are equal, STP, pressures are equal, and both are, right? Both volumes are halved, no? Right? Exactly half of the volume. Then both volumes are halved, which means delta V of both gases is also same. Delta V is also same. Pressure is same. Delta V is same. Then delta W should be same. So work done is same. Right? Work done is same. Simple. Right? It's a simple one. 14. Right. 14. A total of 125 small mercury droplets, each charged to a surface charge density of sigma. What is surface charge density? Charge per unit area. Charge per unit area is called surface charge density. Combined to form a single large mercury droplet. What is the surface charge density of the large mercury droplet? Okay. Then let's say radius of a small one is simple r. There are such 125, and radius of the large one is capital R. Right? So we know when drops are making or breaking, their volumes are equal. When drops are making or breaking, their volumes are equal. Then volume of a small droplet can be written as 4/3 cancels off, 4/3/5 cancels off, r cubed 125, right? This volume is 4/3/5 r cube, 4/3/5 to 435 cancels. Then simple r cube 125 equals capital R cube. Take the cubical root both sides, right? Then 25, right? Cubical root 5, cubical root of 125 is 5. Then 5r equals capital R, right? 1 is here. 5r equals capital R. Right, now surface charge density of the smaller one is given as sigma, no? Then let's assume charge of a smaller one as q, right? If the charge of a smaller one is q, right, charge of 125 such drop should be 125 q, no? Then the larger one has a charge of 125 q. Then the sigma is for a small one q over, right, 45 simple r squared. Let's take this as 1. And then we need the surface charge density of the larger one. Then charge of the larger one is 125 q over radius is 45 capital R squared. Then sigma dash is 125 q over, right, 45 r is 5r, no? Then 5r squared. 5r squared is 5r squared is 25 r squared. 25 r squared. So this is equation 2, right? Divide these two. 1 over 2. Sigma over sigma dash. Sigma over sigma dash, right, equals from sigma q over 45 r squared. 45 cancels. Q over 45 r squared. And here 45 25 r squared. 45 25 r squared over 125 q. 125 q. Q to q2, right? 45 r squared to 45 r squared cancels. Then this is 25 times 5. Then sigma dash equals 5 sigma. Sigma dash equals 5 sigma. That's a good question, right? Kind of a good one. You have to have a good understanding about electric fields to do it, right? That's a good one. 15. If the distance between two masses is doubled, the factor by which the gravitational force between them decreases is very straightforward, right? Doubled means 1 over 4. If you don't know, F equals g m1 m2 over r squared, no? Gravitational force, right? G m1 m2 over r squared, which means F is inverse proportional to r squared. F is inverse proportional to r squared. Then if r is doubled, the impact is, by the square, right? 1 over 4 r squared, that is decreased by 4 times. Right? Decreased by 4 times, right? So approach these MCQs easily. Right. Right. 16. To make ice, water at 30 degrees Celsius is placed in a container and kept inside a freezing compartment at minus 15 degrees Celsius. After 5 minutes, the temperature of the water in the container was found to drop to 6 degrees Celsius. Right. A different question from law of cooling. A different question from Newton's law of cooling. So we know Q over D equals EA theta minus theta R from Newton's law of cooling. Right? From Newton's law of cooling. Then Q is expanded as ms theta over D equals EA theta minus theta R. Right? For the same object, M is constant, S is constant. Right? E is constant, A is constant. Right? Then theta over D proportional to theta minus theta R, no? For the same object. Apply this for these two scenarios given. Apply this for the two scenarios given. Then first case 30 to 6 means temperature difference is 24. Proportional to for theta you have to put the average value, right? This theta here is the average. This is the average value. Then average from 30 to 6 is 18. 18. Then 18 minus 15. 18 minus 15 theta r, right? Then over time is 5 minutes. Then at least how much additional time in minutes will take to form ice inside the container, right? Additional time. Then the temperature drop from 6 to 0 is 6, right? T proportional to then from 6 to 0 means average is 3. Then 3 minus 15 again. Divide these two. Then 24 over 5. This is T over 6, right? Equals from the other side 18 plus 15 means 33, no? 33 over this is 18, right? Then simplify. 6 times 3 here, then 3 times 11 here, right? That's it, no? T equals 55 over 24. 55 over 24, right? That's a 2 point something, no? That is 2.29. It's coming, right? That's 2 point something, no? Then don't simplify because 24 times 2 is 48. Then 55 is 2 point something. Then only 2 point answer here in the given list is 5. So it is obviously 2.29, right? No doubt about it. 17. Consider the following statements regarding a photoelectric cell, keeping the intensity of incident light constant. When the frequency is varied, the potential difference at which the current becomes 0 also changes, right? Potential difference at which the current becomes 0 is called Vs, no? That is stopping potential, right? In photoelectric effect, we discuss this separately as always intensity is proportional to current. Intensity is proportional to photocurrent. And frequency is proportional to three things, right? Kmax, Vmax, and Vs, right? This is the only thing you should know from the theories, right? Now in the first statement, what is given is keeping the intensity of incident light constant. If intensity is constant, current is constant. When the frequency is varied, the potential difference at which the current becomes 0, that is called Vs, stopping potential, also changes. Correct, no? That is correct, right? That is correct. Because current is constant, and when F changes, Vs changes. So A is correct. B, for light of the same frequency, when the intensity is varied, the potential difference at which the photocurrent becomes 0 also changes, no? Because it changes only with frequency. For light of same frequency, it is not going to change. B is wrong. C, for light of same frequency, the potential difference at which the photocurrent becomes 0 varies depending on the metal used for the cathode. That is correct, because we know E equals 5 plus K max, right? E equals 5 plus K max. Now HF equals 5 plus EVS, right? Now if phi changes, Vs changes, even though HF is constant, right? If phi changes, Vs changes. HF is constant because it says for a light of same frequency. Then if frequency is same, HF is a constant, right? And charge of an electron is also constant. Then when phi changes, then from the equation, the other only variable here is Vs. Vs changes, right? So C is correct. Then A and C. It's 4, right? A and C, it's 4. 18. Three liquids A, B and C have temperatures of 20, 30 and 41 respectively. When the equal masses of A and B are mixed, the final temperature was 24. Okay, A and B are mixed, no? Then heat absorbed by A equals heat liberated by B, right? It is written as MSC, no? Now equal masses. Then M SA theta. Final temperature is 24, no? Then temperature difference for A is 4. Temperature difference for A is 4, right? 24 minus 20. 24 minus 20. And for B, MSB, let's say, temperature difference 32 to 24, no? Then 32 minus 24. M to M cancels. Then this is 4. 4SA equals, this is 8, no? 8SB. Then 4 and 8 cancels. Then SA equals 2SB. One relationship is here. SA equals 2SB. One relationship is here. Right? Then it says, when equal masses of B and C are mixed. Right? If B and C are mixed, then QB equals QC. Heat absorbed by B equals heat liberated by C. Then QB is M SB theta. Final temperature has been 35. Then 32 to 35, 3. 35 minus 32. And same as SC 41 to 35, 6, no? Then 41 minus 35, 6. 41 minus 35, that is 6. Then M to M cancels. SB, this is 3. SC, this is 6. Then it says SB equals 2SC, right? Another equation. If these two equations are merged, then SA equals 2 times SB, but SB is 2SC, no? Then 2SC. Then we can write SA as 4SC, right? Another relationship. SA equals 4SC. SA equals 4SC, right? Now it says if the mass of M is mass M of A is mixed with mass 4M of C. Okay, then again QA equals QC. Then from A mass is M SA, right? Final temperature is asked. Okay, then let's assume final temperature as theta. Then this is theta minus 20. A is at 20, right? A is at 20. Theta minus 20. Then 4M from Z, right? SC, C is at 41. Then final temperature 41 minus theta. 41 minus theta. Then M2, M cancels. For SA, I can write 4SC, no? For SA, 4SC. Then 4SC, theta minus 20 equals 4SC, 41 minus theta. 4SC to 4SC also cancels. Theta minus 20 equals 41 minus theta. Then 2 theta equals 61. Then theta equals 61 over 2 means 30.5. Right? 30.5. 30.5. Right? 19. A small object of mass M is tied to the end of the string of length Hn rotated in a horizontal circle of radius R. Horizontal circle of radius R. Okay. Radius R. Such that the string makes an angle theta with the vertical, like a conical pendulum. If the angular velocity of the object moving in the circular path is omega, which of the following is correct? Okay. Then we know the forces acting here. The forces acting here are, right? There's a tension, right? And there's mg. And we know if this angle is theta, this is also theta. Then this component is t cos theta. And the component to this side is t sin theta, right? For a horizontal circle, we do only two things. For a horizontal circle, we do only two things. One is writing vertical equilibrium. From the vertical equilibrium, I can say t cos theta equals mg. T cos theta equals mg, right? From the vertical equilibrium. And the only other thing we do is applying F equals ma towards center. That is common for any circular motion, any kind of a circular motion. F equals ma towards center, right? Then only force acting towards center is t sin theta. T sin theta equals ma, right? A is r omega squared, no? A equals r omega squared. that is coming from circular motion, we know A equals either V squared dou R rho or omega squared. Right, then I need omega, so I expanded using omega. Now, from the triangle here, I can see sin theta is given by R rho H. Right, from the triangle, sin theta equals R rho H. No? From the triangle, sin theta equals R rho H. Now, if I use that here for sin theta, then T sin theta is R rho H equals mr omega squared. R cancels off. Right, then T equals mh omega squared, say equation 2. Right, say equation 2. Then you can either plug T in equation 1 or divide. Right, I'm going to divide. Then 1 over 2 equals T cos theta over T. T cos theta over T. T cos theta over T. Right, and from 1 mg over mh omega squared. Then mg over mh omega squared. T2, T cancels, M2, M cancels. Right, we have given cos theta, then subject cos theta. Cos theta equals G over H omega squared. Then cos theta equals G over H omega squared. That is in 1. That is in G over H omega squared. Cos theta, that is in 3. Right, for 19, it's 3. Right, horizontal circular motion. 20. Right, 20. Two sound sources emitting sound waves of wavelength lambda are kept fixed at a certain distance apart. A child moves between the two sources at a speed of u. Right. Two sources are here. Right. Two sources. And the child moves in between with a velocity u. Right. A child moves with a velocity u. Then let's assume their frequencies as f. Right. In order to hear sound by this source, this is how sound velocity should be coming to the ear of the child, and this is the relative velocity of this child. Right. Then let's say number of beats. Okay. Then let's say frequency heard by the first one. Right. 1 2 frequency heard by the first one is f1. Then using Doppler's effect, f1 is written as sound velocity through air with respect to observer. Now the observer is moving. Right, with respect to observer. Then with respect to observer, sound velocity through air with respect to observer, right, is observer is moving away, v minus u. Right, then v and u are opposite, v minus u over v into actual frequency f, equation 1. Then f2, right, due to this one, then v plus u over v times f, Doppler's effect. Right, now beats is the difference between frequencies. No, we can clearly see f2 is greater than f1. That is very clear. Then f2 minus f1 frequencies, beats is f2 minus f1, difference between frequencies. Then f2 is, right, we can see f over v is common, take it out. F over v is common. If f over v is taken out, v plus u remains inside. And from the other one, if f over v is taken out, v minus u remains, then minus v minus u. Simplify f over v, right? And here v plus u minus v plus u. V to v cancels off. That is, u plus u is 2u, no? 2uf over v. Right? We know v equals f lambda. Right? And from that, f over v is 1 over lambda. F over v is 1 over lambda. Then for this f over v, you can write 1 over lambda. Then it becomes 2u over lambda. 2u over lambda, answer 5. Right? Doppler calculation. Okay, 1 second. Now it's fine, right? Now it's fine, right? 1 second. Yes, sound. Right, then this one 7r, and the velocity at a distance 7r from the surface of the planet is. Right, from the surface of the planet is. Then uh, okay. Then a planetary radius r and gravitational acceleration on the surface is g. So we know we have a proved equation for gravitational acceleration on the surface, right? We have a proved equation for the gravitational acceleration on the surface. G equals gm over r squared. No? Then from this we know gm equals gr squared. That is a substitution we can use anywhere, right? When you need to convert gm terms to gr terms, right? That's a substitution. Right, then what is asked? Velocity. Velocity at a distance 7r. Okay, if velocity is asked, let's apply conservation of energy from infinity. Let's apply conservation of energy from infinity. Now, if this is falling from infinity to this point, right? Then we can say this is point A. Total energy at infinity equals total energy at infinity equals total energy at A. Total energy at infinity equals total energy at A. Total energy at infinity is 0. No energy is at infinity. Then at A, we have two energies, gravitational potential, and kinetic. Gravitational potential energy is written as gmm over r. No? Then gmm over r, and that distance should be measured from the center. Distance should be measured from the center. Then it is 8r from the center plus half mv squared plus half mv squared. Right? Kinetic energy. Kinetic energy. Then switch the terms. Then half mv squared equals gmm over 8r. Right? Half to 8 cancels 4. Right? Now, at the very moment that I see a 4 is coming, right? Check the answers. Check the answers. There's only one answer with 4. Then it must be 2. Right? MCQ patterns set. There's only one answer with 4. No? I can see a 4 is coming. Right? GMGR will convert kara coefficient right? We'll simplify. But this is the moment that you can decide the answer is going to be 2. Right? That's the moment that you can decide it. Okay, then m cancels, simple m cancels. V squared equals gm over 4. gm over 4. gm over 4 में 4r. gm over 4r. gm over 4r. Right? gm over 4r. Then gm is, right? I can use from here, gm is gr squared. Then gm is gr squared over 4r, 1r cancels. Right? Then v squared equals gr over 4, right? V equals square root of gr over 4, right? But no need to simplify up until the last movement, right? No need to simplify up until the last movement, right? We had a point there. We had a point there to you to decide the answer, right? Always check the given answers when you are doing MCQs, right? Otherwise, now if you keep simplifying to the last point, right? Sometimes you might run out of time when you are finishing 50 questions, right? And the other thing is when you do these questions faster, you can save that time for a question that you are going to stuck, because we don't perform in each and every question to the same level, no? Right? We don't perform in each and every question to the same level, right? හැම question එක විදිහට click වෙන්නේ නැහැ. Right? ඉතින් ඒ හින්දා මේ ඒ වගේ ඒවාට save කරගන්න පුළුවන් time එක. Okay, 23. The Young's modulus of an aluminum rod is 7 times 10 to the power 7, and its breaking strain is 0.3%. Which of the following values is the minimum cross-sectional area of the rod must have in order to withstand the load of 10 to the power 4 newtons? Withstand the load of 10 to the power 4 newtons. Right. Then we know Young's modulus equation is F over A equals Y E over L. Right? F over A is called the stress, that is stress, and E over L is called the strain, right? Stress and strain. Then for F, 10 to the power 4, load is 10 to the power 4. I need the area. Y is given 7 times 10 to the power 7, right? E over L, strain is given as a percentage, then 0.3%, no? Then 0.3%, 100. 0.3%, 0.3%, right? Now this is just a matter of simplification now. Just a matter of simplification now, right? Then this is 10 to the power 4. 10 to the power 4 cancels with this, then 10 to the power 3. 10 to the power 3. And with this 100, if this 10 to the power 3 is cancelled, this is also cancelled. Then 1 over A remains this side, and from the other side, 7 times 3, right? 0.3 into 10 is 3, no? Then 21. Then A equals 1 over 21. A equals 1 over 21, right? That you have to simplify. 1 over 21. 1 over 21 is coming as 0.0476. 0.0476, right? Then a rounded answer is given, right? This is coming as 0.0476. This is written as 4.76 times 10 to the power minus 2, no? Right? Rounded answer means now there's a point in this question. Listen, there's actually a point. Now the exact value we get is this, right? Exact value we get is this. Exact value we get is this. 4.76 10 to the power minus 2 square meters. Now in the question, how it asks is minimum cross-sectional area the rod must have in order to withstand the load, no? In order to withstand. Now 4.76 is the exact area that is needed to withstand it, right? Then anything above this, it is withstandable, and the minimum is asked. Then minimum value above 4.76 is 5. That's a logic there. Minimum value above 4.76 is 5. Then answer is 5. Correct. 24. 24 is from the experiment, from our critical angle experiment, right? Because that is from the critical angle experiment. Right? Then the diagram constructed by a student based on information obtained during an experiment to determine the critical angle of a prism shown below, observing the image of pin P through the prism. As he moved his eye from X towards Y, right? X to Y. Okay, this direction. X to Y. X towards Y. Pins Q and R were fixed such that they were collinear with the image at the last movement is O8. So we know from the experiment, right? Experiment in detail when the eye is taken from X to Y, right? X to Y, what happens is, now initially the person is seeing the image because of refraction. Then at one point it reaches the critical angle, and very next moment after that it disappears because it is totally internally reflected, right? It disappears. Then the disappearing movement means the critical angle, no? Disappearing movement is a critical angle. Disappearing movement again. Last movement is O8. Okay. Then the disappearing movement is a critical angle. Right? Disappearing movement is critical angle. And the last movement is O8 is because of total internal reflection. Right? And at the critical angle, he won't see. Critical angle is the diagram that we have got here. Right? Now this is what we have as the diagram, and you should know the rays. Rays are coming from P like this. And the rest is the construction we have done. No? Rest is the construction we have done. And this is a critical angle. Right. Now, when the eye is taken further from that very point, this C increases by a bit, no? Right? This C increases by a bit. When C increases, what happens is this. Right? For the clarity, I will draw it on the same diagram here for more clarity. Right? See? Now, when C increases from this point, the ray is somewhere here. when C increases further, the ray is somewhere here, because at the total inner reflection, it should be a little bit greater than, C, no? Right, something like this. Now, if you draw a normal here and check the ray, since C is greater than that, this is going to come somewhere here. It is going to come somewhere here. Got it? That is going to come somewhere here with the total inner reflection. Then definitely I can say this image he has seen should be in between this range, no? It is in between this range. Right? It is in between this range. There's no other place that it would go, because finally that is at Q. At the critical angle, then at the total inner reflection, it should be somewhere in between Q and that prism. It cannot be E and C, because they are outside the prism, right? Make internal reflection, then only answer given to satisfy that is D. Right? Then 24, it's 4. And the basic behind this question is coming from the experiment, refractive index of a prism using critical angle method. Right? That's a good question. And it has questioned as MCQ. Right? Usually, from the experiments, MCQs are like not that popular, no? There had been cases where MCQs has come from experiments, right? But not that popular. This is such a question. Right? This is such a question. Okay, 25. Last one for the day. As shown in the figure, a child inside a trolley attached to a spring undergoes a simple harmonic motion horizontally with a frequency f. Right. So we know frequency of a simple harmonic motion is given by, but before frequency, what about periodic time? Periodic time of a simple harmonic motion is given by, that's a spring, right? Of the spring is given by m over k, 2/5 root m over k. Then frequency is 1 over d, no? Since frequency is 1 over d, frequency is given by 1 over 2/5 root k over m, right? 1 over 2/5 root k over m. Then its amplitude is A, and its speed at the center of the oscillation is Vm. At the center of the oscillation means that is the maximum speed, no? Right, about Vm also, that is a special point. That's a special point. We know at the center, that is not another velocity. That is the Vmax. Vmax equals A omega. Now, in this case, that is given as Vm. Then Vm should be A omega. Vm equals A omega. Right? Then, at the moment the trolley passes its center, the oscillation, center of the oscillation, the child gently releases the sandbag. Sandbag means that's heavy. Sand that was inside the trolley, out of it. Consider the following statements regarding the subsequent motion. Okay, so first thing I can notice is when the sandbag is released, mass attached to the spring. So mass attached to the spring, because our springs are always light. Mass attached to the spring decreases. When m decreases, then frequency increases according to this equation. K is a constant because the spring remains constant. Then frequency increases is greater than f, then C is correct. That is the first one I notice. Right, then about maximum speed, it is asked. About the amplitude, it is asked. Right, about the maximum speed. Right, now that is at center, no? That's a special case. Right, it's a special question actually. See, at center we know, at center of oscillation, what about x? X is 0. If x is 0, right, acceleration is also 0, because A equals minus omega squared x, then acceleration is also 0, right? And if you check force is also 0, right? For a simple harmonic motion, F equals minus kx on the spring, minus kx or kx. Since x is 0, force on the spring is also 0. This is a good point. force on the spring is 0, right? If the force is 0, velocity cannot be changed because there is no acceleration, right? To change a velocity, there should be an unbalanced force and an acceleration or a deceleration, right? That is coming from our basic equation F equals ma, no? Then if there's no force and no acceleration, then velocity cannot be changed. That's a good point in this question, no? That's a very good point in the question. Since that is at the center, if it was not at the center, then it changes, right? So that's why especially that is given as it releases at the center, passes the center of the oscillation. Then when center is passed, there's no acceleration, there's no force. Without any external force or any unbalanced force in the system, velocity cannot be changed. Then velocity remains unchanged, right? That is the point where you have to make this decision, right? A equals 0, F equals 0, then because of that, velocity is unchanged. Right? If velocity is unchanged, Vmax is unchanged. The maximum speed of the new oscillation is also Vm. That is correct, right? That is also Vm. That is correct. See, that is correct. That's a good one. V is unchanged because there's no unbalanced force or acceleration in the system at that particular point. Then it cannot be changed. Right. Then, if you know about V, now we can argue about amplitude using this equation. Right. Vm equals A omega. Right. Now, Vm is unchanged. What about omega? You know relationship between omega and frequency. Omega equals 2 phi f. See how these equations are connected. Now you should be able to play around with these equations like this, right? All are simple harmonic and circular motion equations. Right? Then omega equals 2 phi f. Frequency was increased. When frequency increases, then from this omega increases. Then if omega increases, left hand side of Vm is constant, this equation is constant, then amplitude must decrease. Then amplitude of the new oscillation is less than A. That is also correct statement. Then all ABC are correct. That is 5, all ABC are correct. Right? That is 5, all ABC are correct. That's a good one, no? That's a good one. Right. Okay. So I planned for 25 questions today, right? And we have come to the end of 25, and I will take the remaining 25 on another day, right? Very soon. And since the English translation of this paper was not available, I found everywhere and it was not available. Then finally I had to translate, right? So only first 25 are translated now, and I will get the next 25 also translated. And the best calculations of the Southern Province paper was in the last 25 questions actually, right? The best calculation type questions. Because in this first 25, they were more towards like statements and simple calculations, no? Right? There were good advanced calculations, right? Advanced types of calculations towards the towards means in between 30 and 30 to 50. The last 20-25 questions were the best ones, best calculations here in Southern Province 1. Okay, so I will let you know what the date that I'm going to take for the next 25 questions, right? Any questions from the things we discussed today, from these 25 questions we discussed today? Any questions? Anything to clarify? Now this is Saturday now, almost. I mean, now it's 12/7. So it's Saturday. It's Saturday means we have exactly 8 days to the exam. Exactly 8 days. Right. It seems no questions. Right. Then if no questions, we can wind up, right? So reminding again, you are exactly 8 days now, right? Exactly 8 days from the exam. 8 days from the exam, right? So manage your time with the things, with the subject matters, right? And by the next weekend actually, you have to finish all your regular work and you have to start or allocate the coming weekend to the subject you are having on 10th, right? Combined maths or bio, right? Combined maths or bio. Then finish this regular working routine by Friday, and you can allocate the rest of the days for the subjects as it goes, right? So in the class I gave you a plan also. Plan එක හරි ඔයාගේ plan එකට හරි ඕන එකට වැඩ කරන්න. It can be your own plan or the plan I gave or anything. Doesn't matter. It should be something comfortable to you and something that your goal and the target is served. It should be something your target is served, right? So don't just work here and there, right? So last 8 days, and we have to stop the classes by 4th, I think, right? By 4th, I guess. Then by 4th, we have to stop the classes. Sometimes I might be uploading some recorded videos if needed, right? And other than that, the past paper discussions and those things are going on, right? Essay discussion එකකුත් තව එකක් මම කරන්න තමයි plan කරලා තියෙන්නේ. So we'll be having another essay discussion also, right? All right, then if no questions, I will wind up without wasting any more time, right? So even 1 minute matters these days. Even 1 minute 30 seconds even matters these days. 30 seconds කියලා කියන්නේ තවට MCQ එකක් හරි කරගන්න පුළුවන්. All right, then we'll stop, right? We'll stop. So work hard, stay safe and stay healthy. Work hard and see you in the next class or next session. All right, goodbye and good night. See you.